All right, folks, it's Bass Action, back in action here. On this page of notes, what we're going to work through are 3 examples for our side-side angle pattern, and the 3 examples we're going to work through are going to match the 3 pictures that I discussed in the previous video. So we're going to see how algebraically we can determine whether there's 1 triangle, 2 triangles, or no triangle at all. So let's look at our example 1 here and notice that we are not going to draw this triangle to scale. So we really have to depend on our math and not our eyeballs. So what we're going to do is we're going to start off with our triangle, and remember, it doesn't really matter what your triangle looks like. I'm just going to draw this first triangle. I always start on the lower left and go clockwise, so I'm going to name this triangle ABC. Now my uppercase B with the degree symbol tells me that this needs to be 37 degrees. My lowercase a means side A, so that's going to be across from angle A, so I got a 13 there. And lowercase b is across from angle B, so I'm going to have a 9. So what I'm going to notice right away here is that I have 2 sides and a non-included angle. So I don't have a side angle side pattern, I have a side side angle pattern, which means we have to determine whether or not there's 1, 2, or 0 triangles. Now, we already know that what this one's going to turn out to be, but in general, when you have a side-side angle pattern, you always want to draw that potential second triangle, and it's important to recognize this is a potential. We don't know for sure, unless we already have it drawn to scale, what's going to happen. So what we want to do first is we want to determine where's our hinge. The hinge is always going to be between the 2 given sides. So we're going to first identify that hinge. It's going to be right here at C. Then we need to figure out what side is going to move, and the side that's going to move is always going to be the side that's across from the given angle. So what we're picturing is that this side here is going to swing inside, and it's going to create this other potential triangle. So when I draw this, what I like to do is I like to draw the 2 sides that I know are going to stay the same first. So I'm going to draw that first, and I'm going to get my 37 degrees in there, and I'm going to have this 13 that's going to stay the same. And then when I draw in that new side, I am not trying to make this look to scale. I just want this to hit somewhere along that side, and I'm going to call this a C prime because it's going to be that new C. I'm going to call this an A prime because it'll be a new angle A, and I'll have my original angle B. Now, this A prime, C prime has to stay as a 9 because that's the whole idea with this moving the side in, that the original measurements have to stay the same. Now, I do also like to indicate here, I'm going to put a couple little dots. We talked about these on the previous page. I'm going to put a little dot right here. So once I find the measure of that angle A, when this swings in, it will become this exterior angle. That's going to help us keep track of things on where all these numbers are going to go, because our picture's not to scale, so it's going to be a little hard to follow. All right, so let's go ahead. Now that we've drawn our potential first triangle and our potential second, we can start to do our algebra here. And we notice that we have a link. We have the measure of a side and the angle across from it. So I've got this link right here. I'm going to use that to find an angle first. So when I set up my law of sines, I'm going to have my 9 over my sine 37, and that's going to equal my 13 over my sine of A, and the fact that I'm looking for an angle tells me I'm going to need to use my inverse sine function in a little bit. So now I'm going to cross multiply this, and without having to write everything out, what I know I'm going to get is the product of 13 times sine 37 divided by ultimately 9. So I'm going to jump ahead here and write this out as the sine of A is equal to the product of 9 times sine 37 divided by 9. Now, when I type this in my calculator, remember what we're ultimately doing is we're ultimately taking the inverse sine of each side of this so that we actually get the measure of angle A. So when you type this in your calculator, what you should be getting is 60 degrees. Now, if you're not getting that 60 degrees or you don't know how to handle that in your calculator, don't stress about that right now. I can show you how to do that in class. That's the least of our concerns. The most important thing here is understanding how I'm setting this up. So if that angle turns out to be 60 degrees, what we will be able to have and obtain is every other angle in these two figures. So this angle here is 60 degrees, which means this angle on the other figure, remember the dots had to match, so this angle in our other figure is also 60 degrees. Now from there, we can fill in the rest of our triangle. So let's look at this triangle first, the original ABC. If I have a 30, a 60, I can get the remaining angle of C by subtracting from 180. So this angle is going to be 83 degrees. That triangle certainly makes sense, so we'll finish off and get our last side here in just a little bit. Let's go to the potential second triangle and see if it makes sense. So if I have a 60 degrees here, I'm going to have it supplement. So that means that this angle inside here is going to be 120 degrees. Now, 120 plus my 37 gives me a 157. That means that I have degrees left over for my last angle. So this potential triangle does in fact exist. So this angle here becomes 23 degrees. Just thinking the sum of the angles in the triangle needs to be 180. Now, that we can see that we've got two triangles with acceptable angles, we can go back and we can find the last side in each triangle. So I'm going to find this side C right here, and in my other triangle, I'm going to find the side C prime. So I'm going to set up my law of sines one more time. The original link that we used in the very, very beginning is the same link that we're going to use again. So I'm going to do my 9 over my sine 37, and that's going to equal my original side C over sine of 83. Remember, C is across from 83. And then I'm also going to set up my other law of sines question that's going to say 9 over sine of 37 is going to equal C prime over the sine of 23. Now, these problems are just like our very original first day of law of sines, so we can simply cross multiply. So we're going to have the product of 9 times sine 83 divided by sine 37, and I won't have to do anything special. We're not solving for an angle, so we don't have to worry about inverse sine. So once we type that in our calculator, we're going to get C is approximately 14.8 if I'm rounding my sides to tenths. On my other, I'm going to do this cross multiplication, so I'll have the product of 9 times sine 23 divided by sine of 37, and on that, I'm going to get a C prime of approximately 5.8. Again, I'm rounding my side measures to tenths. Okay, so there we can get all of our measures, even though our picture wasn't drawn to scale, so that one was no big deal. So let's go down and look at our example 2. Again, we know what this is going to look like because on the previous video we looked at what this was to scale. So what we're going to do is we are going to draw out our first triangle, and it's always a potential because remember the possibility exists that it's not going to exist, that the triangle's not going to exist at all. So I've got this triangle ABC. I'm going to put my 103 degrees on there even though my picture doesn't look obtuse at all. Then I'm going to do side A is 22. I'm going to do side C is 14. As soon as I recognize that I have a side-side angle pattern, two sides and a non-included angle, I'm going to think, hey, I need to ponder where that potential triangle is and what it might look like. So I'm going to find the hinge. The hinge is going to be between the two given sides. The side that's going to move is going to be the side that's across from the given angle. So this side here is going to swing to the inside and is going to create a new triangle. So I'm going to swing that in. I like to draw my two sides here first, and then I'm just going to drop in this side that swung in. So I'm going to have my 22, my 14, and my 103. I'm going to put my A my B prime, since it's now going to change, and my C prime. And now I'm going to set up my trig. So when I set up my law of sines, I find my link. There's my link. I'm going to find angle C first. So remember, once I find this angle C, it'll become the exterior angle on the other side because it's creating an isosceles triangle with two congruent base angles. So setting up that law of sines, I get 22 over sine 103, oops, 103, there we go, equals 14 over sine C. As soon as I know I'm solving for an angle, remember I'm going to have to do my inverse sine. So now when I set this up and I type this in, I'm going to do my inverse sine. If we want, we can write this out. Sometimes students really like to see this written out. 14 sine 103 divided by my 22. And what I end up getting for my angle C is I get approximately 38 degrees. So if I take that 38 and I put it up here in my picture, that 38 is going to be the same as the 38 on the other side, because remember the dots have to match. So now we can continue filling in all of our angles. So if I go back to my original triangle, if I fill in my third angle, my angle B, it turns out to be 39 degrees. So this triangle, when we're done, is going to be almost isosceles. It's not going to be perfect, but it's going to be really, really close. And then when I look at the next triangle, that potential second, these two angles are going to be supplementary. So if I fill in the supplement there, what I'm going to get is that this angle is 142 degrees. Well, that triangle is not going to make any sense. I certainly can't have two obtuse triangles. I've exceeded my 180 already, so the second triangle doesn't exist. Second triangle does not exist. So then you would just stop. You wouldn't have to do anything with that, but we would need to finish off the original triangle that does exist, that has valid angle measures. So we do still need to find this side B. So we'll do our law of sines one more time. So we're going to do our 22 over our sine 103, and that's going to equal our side B over the sine of 39. And since we're expecting this to be an almost isosceles triangle, we're expecting to get a B value that's somewhere around 14. And sure enough, when we solve this, we end up getting 14.2. So that makes sense, something just slightly bigger than the side that was across from the 38. Okay, last one that we're going to do here. Again, we already know what's going to happen, but let's go ahead and draw it. You'll notice that I didn't give you any space to draw the potential second triangle on this because we already know what's going to happen. But in reality, if this were outside of a note-taking situation, you would actually set up the potential second triangle, even though it also might not exist. So remember, it's possible that neither your first nor your second actually exist. So I've got an angle A of 62 degrees, and I have a side A of 5.6. and I have a side B of 13.5. So what you would do is you'd recognize you have two sides and a not included angle. Typically we would draw that second triangle, but we're not going to here. We just want to analyze the algebra on this one. So when I analyze this algebra and I go to set this up with my link, find my link, and I set this up, I get my 5.6 over my sine 62, and that's going to equal my 13.5 over my sine of angle B. Now, when I set all this up, I get sine B equals 13.5 times sine 62 all over my 5.6. Now, if you type in this right-hand side of this equation, what you should see now in your calculator is you should see that you have sine B equals 2.13. Now, we know from our unit circle and our domain and our ranges from our sine function that having a sine value of 2.13 doesn't make any sense, because sine is supposed to, of course, be my opposite over my hypotenuse, and it doesn't make sense for the opposite leg to be more than the hypotenuse. So this is kind of red flag number one, that the triangle is not going to exist. If you actually type this in and you do your inverse sine of this, you're going to get a domain error. So that's the second place. So either you recognize it here or you type it in your calculator, but either way, we're going to see that there's no triangle at all. So when you get to this point, sorry about that, can't seem to spell. So we're going to say no triangle. And you would just be done. You wouldn't have to show anything more than that right there. All right, that's all that we've got, and we're going to practice more with this when you get in class.